Up until now, our robot has been a puppet. We pushed the buttons and it moved. But a real companion doesn't wait for commands, it anticipates them. Today, we're handing the keys to the robot over to an AI. I'm using the Gemini CLI directly in my terminal to write the navigation logic in real time. No manual coding for 3 hours, just high-level intent translated into raw Rust2 Python nodes. The goal is simple, but the math is gritty. How do you get a quadrant? To understand where it is, x, y, and where it needs to be. In this session, we're pushing Gemini to generate nodes that handle everything from simple coordinate targeting to complex path following. You're going to start by hitting a single point, then a sequence, then the rectangle test, the classic benchmark for a robot precision. But the highlight of this session is the dynamic chase. I've asked Gemini to create a node that listens to a moving target. I'll be controlling the rabbit with my keyboard, and the dog has to hunt it down autonomously. This is the foundation of the companion phase. If it can follow a visual target today, it can follow my actual dog in the living room tomorrow. Is the AI-generated code perfect? No, not yet. But I want to show you how to use AI as a force multiplier. We aren't just copy-pasting, we're iterating. We're going from a prompt to a moving, thinking machine in minutes, not days. The neural meets the hardware right here. Let's fire up the Gemini CLI and start the first node. Let's see if we can get this dog to follow its first command. I have started running the simulation here, and then let's go. We have a few CLI command windows, and we'll start from here. Let's start Gemini and ask it to actually implement the code for us. Let it load up. Okay, here we go. So this is the prompt I'm going to use. You'll see it. Let's hit enter. So it's basically I'm working on a Rust2 and Gazebo simulation for quadruped, a robot dog. I need to write a Python-based Rust2 node that makes the robot walk in a rectangular path of 2 times 3 meters. Analyze my existing code base, identify the correct CMD well topic and the specific message. Structure needed for JIT. Geometry messages twist. Write a script that uses simple state machine or time-based logic. Move forward for a set duration. Execute a 90 degrees turn. Repeat. Let's see what it's going to do. So I started reading the source file directory. And it's reading the files to understand the structure. I have not seen anyone using this kind of Gemini CLI approach, so let's try it. It will help us save a bit of time and energy and focus on more important things later on. Meanwhile, as writing the code, we can look at the code and learn how it works. 2 minutes 30 seconds. So far. Okay, here it is. Yes, I accept the changes. I accept again the changes for this session. So it runs the shell command chmod to make it okay. I will check cmake. I will examine robot controller. Let's see what it made. World robot controller rectangular box. So it wrote this code for us and imported these libraries. Let's see what it has done so far. Okay, so it defined a class named rectangle walk has no defined init. So publishers, it has two publishers, cmd well pub and mode pub. Rabbit mode command, rabbit mode, and then the subscriber Odometry is listening to this. Service client, self behavior client. Okay, so let me check actually rqt command as we looked at it earlier to see if anything has been changed here, if any new nodes have been added. So let me local map, broadcaster server, map server, smoother navigation. Okay. State controller, robot 1, transform. I can't see it yet. Let's see what it's gonna do. We'll check it again later, so I assume that it should pop up somewhere here after the code run is done. Okay, let's do this. So we come into a new window. We're already okay. Let me run this command to go to this directory. So we have run this command already, but let us run it once again. Doesn't bother. Run quadruped controller rectangular walk. No executable found. And the robot is not walking or doing anything. So let's us report back to Gemini. This is what I got. Allow once. What do you want to do? Let's see, make list of text. Okay, so it needs to install it. Okay. Now, alternatively, we need to build again. Okay. Cool. And source the setup file and clear. Let's run the command. Sending a stand mode, calling walk service, odometry received, starting sequence, moving forward 3 meters. So it's trying to do something, but it's not able to. So let me run this Python command as well. I don't think I have installed Python packages. Okay. Okay. Let's ask it again. Now the code seems to run, and this is the output, but the robot does not move. I doubt that Odometry is not working and or initialized properly. Check if it works. Otherwise, find the root cause and solve it. And this is the log I copied. I will read the REST controller part to see how it handles velocity commands, and then add debug logging to rectangle walk. Okay, we accept this for this session. No, I've updated. You can start again run. Okay, so let me break this. Clear here and rerun the project. And standing on the Odometry, moving from a distance forward. Okay, so let's break it again and report. This is what I got. So meanwhile, let me take a look at the code to see if I can understand what it's doing. So it declares these variables for this class: current odometry, start odometry, self-state initializing, goal distance, goal angle, initially out. Now self timer, self create timer, get logger. Okay, self sequence, move. What's changing? So it's changing to CMD well with this command. Let's allow it for this session. So it has a move command, then a turn, then a move, turn, and move. So it's sending the velocity vectors to be used by the dog. So it will move with 3 meters per second or something, 3 velocity units, then do a turn movement with this velocity and so on and so forth to complete the rectangular pattern. Odometry callback, get yo, normalize angle. Okay, now I think it is kind of done. I have updated the script to publish. So what was wrong? Anyways, let me run it and we'll read it later. Okay, it works. So it is moving from 0 to 3 and okay, it is stopped. Nice, doing a turn, running 2 meters in the y direction, stop, turn, okay, nice. It's doing the job. So Gemini helped us to make the robot work in a certain value. Okay, it repeats. And okay, frame sequence completed. Done, nice. So let's ask it to, instead of going in a rectangular, following a rectangular path, go to a certain location that we ask for. So now create another node to move the robot and make it walk to a certain XY location in the map. So wait, let me see what was wrong with the code that it didn't walk for the first time. So I have updated the script to publish robot velocity message directly to the robot namespace by passing the scaling issue. So it does a scaling thing. I have calibrated the speed to stay within the robot's maximum limit. So the maximum limit was like this, which should be enough to trigger consistent jet in the simulation. Please run the node again. Okay. Allow once. Now allow for this session. I don't want to accept it each and every time. Which file was this? And file, go to goal.py. Nice. Allow for once. Allow this session. So it added the script to the CMaker. CMake lists. So we have this script as well, which we need. Now we need to rebuild this. Let me clear this window. Okay. We are rebuilding and doing the source command and rush to run good rabbit. Do this, go all the way down. Okay. Let's see what it's going to do. Okay. Rust to run quadrupt controller, go to goal. Rust args p goal x, p goal y2. Okay. Let's see what it's going to do. So it's here and it starts doing a rotation and goes distant 3. Okay. Goal reached. Okay, let's give another thing. So it is at 3, 2. And let's ask it to keep the same x and go to -5. Let's see what happens. So it will turn and go along the y direction of the world. Okay. So we have it here. Okay, goal reached. Another error. It's okay. Yeah, it went all the way from here to here. And okay. Now let's try another thing and make the pass a little bit more complicated. So maybe I want to, instead of giving a setup, I don't know. Let's try this. All right. Another node to give the robot a set of coordinate locations x and y, and go and walks towards them in a sequence instead of having it do a twist and then walk toward the goal. I want it to twist and walk at the same time when possible to follow a smoother and more natural path towards the goals, instead of walking in straight lines. Okay, now it gives the follow pass waypoints at okay, it defines these values: max linear well, max angular velocity, odometry, callback, define, normalize. So, okay, I gave you the permission already. Okay, run the shell ch mode, and now I think we need to break this, and it adds it to cmakes list. Yes, do it, and I will have to, let me just copy paste them here from here. Okay, we need to rebuild it, source the setup file, and run it. But the one thing in this code, the locations and the coordinates are predefined, but I want to give them as arguments when I'm running this. So let's see. So it's starting the twist. Okay, twisting and walking at the same time. Cool. Okay, now it turns as, okay, waypoint 0 reached, 1 reached, and now it's walking while, nice. It's going to the third location, waypoint 2 reached, and then the final and fourth one. So let's ask, this is working fine. However, I need to pass the coordinates when I am running the commands instead of commands as arguments, instead of hard coding it in the Python file. Okay. So instead of having, so it's changing this part instead of defining it at waypoints in this class. So it defines default waypoints, which are the same as before. But if we have another set points, it loops over them and defines them as new waypoints. If not, logger error, no valid waypoints provided, return. Okay, nice, accept this. Okay, run the node using the P or parameter flag followed with list. Okay. Let's break this, clear up here, and let's define this, but before it has file breaks and it won't work, and let me do this. So it goes to 3 0 3 3 0, 0, so it's kind of a triangle, I suppose. Okay, first it has to go to 3, 0. So, okay. Okay, so 1 is reached. It goes to 3, 0, 3, 0, 3, 3, and then to 0, 0 back here maybe. Instead of going a straight line, it follows an arc kind of thing, as I requested to do the twist and the walk at the same time. Okay, nice boy, good boy. Cool. Okay, that's good, great. So Gemini CLI took over the Ross and Gazebo and our dog and commanded it to do certain things. So let's try another thing and see if we can make it a bit more dynamic and complex. So what I'm trying to do right now is I want to make the target location a bit dynamic. Instead of giving predefined x, y, or coordinates, I want to have an object and I want the dog to follow this object or target location to reach. So let's start with Gemini again. Okay. Now I want to make target reaching dynamic. I want to define a dynamic target and have the dog following where it goes. The target should be shown in the simulator, and for now we may control its location by keyboard commands. Keyboard. Let's see if it's possible, or we should think about something else maybe. Okay, I will start by searching codebase for marker to see how visualization markers are currently implemented, which will help in creating a dynamic target in simulator. I will search for spawn. Okay, it created the files, image list, dynamic target pi, and that's it. 2. And let's see. I will create Gaussian dynamic follower pi. It asks me every time, I don't know. Okay, switch mode. And again, dynamic target. So it created 2 files. One is called dynamic target, one is called dynamic follower. And now it adds it to CMake list. So we have to clear here, build again, we need to do the source and do this. Okay. Calling walk and another terminal. We may need to do this. Use WASD to move the target. I don't see the target. It is moving somewhere. I'm using WSD. Okay, so it's obviously reached, but let me use D on the keyboard to move the target a bit to the right. Okay, and now it follows it. So it's reached. Okay. Now if I use W to move it a bit forward, I think it should do it. So the forward is here, but I can see no target. So it does actually what we want it to do, but I cannot see the target. The robot seems to follow a target, but the target is not shown on the simulator. 2, when I use WASD to move target, I want to see the coordinate XY values in the terminal. I will update dynamic to provide terminal feedback, XY positions, okay. Right, I'll go sim with Gazebo region. Okay, print E. Okay, it wants to print target positions in the terminal using print command, print position x20. Y, okay, moved to, okay, let's accept it for now, see what it's going to do. Okay, run the needs as before. In our viz, if you don't see the red sphere, click add bottom left. Okay, so we are in our viz. Actually I can see nothing, not the dog and not the target. Terminal feedback, marker, frame fix. I change frame ID from map to Odometry, which is a standard reference frame for Ramos movement odometry. This should make the red sphere visible in our viz. Like at bottom left, select marker by display type, or okay. Bottom left. Okay. And select marker by display name. Marker. I don't have anything like that. Ensure the topic is set to target marker. Odometry. I actually. Okay. And where it's one frames. TF. Map. Marker. Topic is set to target marker. Okay. Ensure the fixed frame in RS is set to Odom. Fixed frame. And set to Odometry. Okay. And where the heck is this going? It's going infinite. Okay. Ensure the fixed frame in RS is set to Odom or Robot 1 Odom. Robot. Do we have anything named Robot? No. So let's Odometry. And that's it. Okay. So let's rerun this for now. Controller. And again this one. And so it's going there, but we are too far away from that. I don't know. Okay, so let me move the target a bit. So I wanted to go to 4.9, 2.6, 4.5. Okay, so that is going there. Let me see if this is moving or not. It is. Okay, so I can see the marker here, but I cannot see the dog. Now, after these changes, I can see the marker in our Wiz. But I cannot see the dog. I only see the marker and a dashed line from center to some unknown far location. I should have reported also these numbers and the difference. This is a timestamp, I think. Okay, let's shall rest to node list. Yes, you're allowed to do this. Okay, no problem. Color A, slightly more opaque. I don't care about that. And actually, it didn't change it. Whatever. And the control, please let me know if the dog is now visible. Okay, Control C. And the ripple controller. Okay. What's this here? It's an arrow. I don't know where it is, but let me also rerun this. Where are you going there? But I still cannot see the dog anywhere. Let me see if I can move this a bit and see the dots moving. No, target is stuck there, so okay. I cannot see the dog in Arvis. I can see the target, but its location does not update when I use WASD to move the target. Do I need to run any other commands first or relaunch the simulation? Okay, we need to rebuild it first. Let me allow. Oh, it's not finished yet. Header, odometry, robot one odometry. Key action for a rebuild. And let me stop this too. Clear. And out. Oops, I copied run as well. Okay, now we have to do the source and then an RS or display. Now I run the, oops, no. Clear again, and actually run the counterpart controller, and here we run the dynamic target definition, and now we have the marker here, and now I can use WSD and see if it updates. Yes, it updates. Let me do this, and now the target is here. Let me see if I can follow this line where it goes. Okay. The marker moves, but I can still, I cannot see the dog yet. There is an dashed arrow from somewhere. An infinity towards the center of the map. I need to see the dog on or with. Find the red cows and solve it to show the dog. Let me make it like this so we can have the both windows here in the side. And now let's make it smaller. Okay, now we can see both sides of that. 2. Okay, I declare parameters. Okay, again, clear build source the file and relaunch drummer dynamic. Let's repeat it here as well. Okay. if I move it using these commands, set fixed frame to odometry. It is set to that. Add a robot model display if not already present. Robot model is present. Status OK. Visual enabled. Add marker display. Marker display is already added. Marker array, map. No map received. Topic map. Robot 1 map. Okay, whatever. Okay, so far it's good for today actually, this session. We asked everything to do, so now we can do certain pattern follow certain paths, go to certain locations and follow a sequence of locations, and also follow a moving and dynamic target. So I think it's good. We'll deal with the RViz window later. Okay, here we are. We just went from a static model to a robot that can hunt a target across a coordinate plane, all driven by AI-generated code. It's not just a simulation. It's a proof of concept for the brain I'm going to put into the physical chassis of the Project Paw-Step. If you're just joining us, this is all happening in the Neural Lab. This playlist is designed to take you from dependency hell to autonomous reality. If you missed how we set up this environment or how we wiretap the robot's nervous system, go back and watch the first 2 sessions. In the next session, we're moving beyond just following a ball. I'm going to teach certain behavior that this robodog, that my own dog Jimmy, is doing. If you want to see 100 fails and the one big aha moment that follows, hit subscribe. Join the journey of building an intelligent companion from the first line of the code to the first physical step. I'll see you in the next